This conference will now be recorded.
Very good evening, students. We are discussing current and electricity chapter. Basically, the previous year's JEE Mains paper. We are taking up various questions on that particular topic, current and electricity, from various JEE papers and trying to solve. So today we have few questions to discuss. So the question you see here, it is from IIT JEE Main 2019. So let us read the problem and then we'll try to solve it. The problem says space between two concentric conducting spheres of radii A and B, where the radii of B is greater than the radius of B is greater than the radius A. Okay, so we have two concentric spheres. One has radius A, another one has radius B. So B is greater than A, and the space between these two concentric spheres is filled with a medium of resistivity rho. The resistance between two spheres will be, there are four options, you have to find out the correct answer for this. So what will be the resistance between the two spheres? Let me show you. Okay, so this is, see, this is representing the problem itself. So there are two spheres. So this is the bigger sphere, you can see, having radius B. Another one is the smaller sphere having radius this, and in between the space, that means this space, okay, this space in between is filled with a medium having resistivity rho. So what is the resistance between these two spheres? That means if I connect this at this place, one conducting wire and another conducting wire here, and connect it to circuit, how much resistance it would show? That is what you have to find out. Look, we know resistance can be written as resistivity rho L by area. Okay, so in this case the space between this is also having spherical or kind of, yeah, spherical symmetry and having uniform resistivity everywhere. So what you can do, we have to actually find out what is this L by A. This is constant anyway, L by A, this thing we have to calculate. So for that, what we are doing, let us consider an elementary disk having radius x. Okay, disk, I mean to say, not disk, it is actually elementary spherical cell. See, spherical cell and disk, it is different. Spherical cell I am considering. Suppose I have a spherical cell. I am considering, in fact, two concentric spherical cells. Okay, two concentric spherical cells having one having radius x and another one has radius x plus dx. So these are two concentric spherical cells. Okay. Now, if you integrate the area of the spherical cell, okay, spherical cell over this dx, then you will get the area of the space between this. Okay. So what we do, let us say the resistance of this elementary cell, okay, or space between these elementary cells is dr, which is equal to rho. L means thickness here, dx, and what is the area? Area of that portion will be 4 pi x square. Okay. So now if we want to get the resistance of the whole region between A and B, then area between A and B, then see we have to integrate it. So resistance has to be integrated over A to B dr, and this integration will be over x actually. So here we'll put the value of dr. Dr is rho dx divided by 4 pi x square, right? So this is rho by 4 pi A to B dx by x square. If we integrate it, we'll get the resistance between at the area or the space between A and B. So that will be rho by 4 pi. So integration will be 1 over x and limit will be A to B. So it will be nothing but rho by 4 pi whole into 1 over A minus 1 over B. So this will be the answer. Let us see, let us match the answer. The answer is rho by 4 pi A minus B. So this B, answer B, like option B will be the answer for this question. Okay. All right, we'll go to the next problem. This is also an interesting problem. Let us read the problem, and I have not given the options here. I'll write the options. So in an experiment, the resistance of a material is plotted as a function of temperature. You know, this is a very well-known curve, resistance curve for a metal. Okay. For a material, it is given like this. Not metal, it is for a material. Okay. As shown in the figure, it is a straight line. It is a straight line, as you see. One may conclude that the resistance can be represented by the equation R of t equal to R0 e to the power minus t square by t0 square. Option B says it is R of t is equal to R0 into e to the power t square by t0 square. I'll clean it. T square by t0 square. Option C is rho of t is equal to R0. Sorry, R of t is equal to R0 e to the power minus t0 square by t square t0 square minus t square, then last option says it is r of t is equal to r0 e to the power, sorry, not e to the power, r0 by 2. It is r0 by 2, sorry, t, r0 by t, r0 by t square. Alright, so these are the options. You have to find out which one is true. See, from this curve, what we can say about the straight line? First of all, it is related to the equation of this plot. Like which equation can be represented by this plot? Okay. So let us first do one thing. Write down the equation for a straight line like this. So this straight line can be written like equation, general equation for this straight line will be y is equal to mx plus c. This is in general. So here it will be minus because the slope is minus, negative. Okay. Okay, because slope is negative, so I can write y is equal to minus mx plus c. What is the y here? Y is this ln RT, and x is what? X is 1 over t square. So this equation can be written as ln r of t is equal to minus m, let it be like this, m x means 1 over t square, so t square plus c. So this is an arbitrary constant. This constant is actually this much. This is the constant. Okay, so it is actually the intercept on the y-axis. It will be somewhere here. Okay, this is anyway positive. Intercept is positive. Okay, so in this case, this intercept can be sometimes written as, since this is r0, we can actually write this as ln r0. Just by intuition, I can write it. Okay, by seeing the equations in all cases. So this would be the equation, kind of equation. This m is anyway some constant. Okay, m will be some constant. We'll see that. So, and obviously that constant will be this m slope, because this has this constant slope. So this will be also a function of temperature, as you see, because y by x will be the y by x will be the slope. So in this case, if we write y by x, so it will be t square by ln rt sine, kind of that. Okay, so this is kind of the slope here. So we'll see with all we'll see Okay, so what we'll do, we'll take up each equation and try to take logarithm of that. Let us take first equation. Let us take the first equation and take logarithm both sides. So it will be, logarithm means ln r here, ln r of t. So this will be ln, since it is whole thing, I'll write here first, t square by t0 square. Okay, so this will give you ln r0 plus e to the power of this, e to the power, and when you take the ln, it will be simply simply the argument of the logarithm according to the law or the formula of logarithm. We can write this as t square by t0 square. Okay, all right, so this is ultimately this will be actually kind of this. Okay, look this equation. Suppose this is equation number 1 and this is equation number 2. Are these two matching? No, because T is here, T0 square is down. T0 means a constant temperature, initial temperature or constant temperature. Okay, so this cannot be correct because T here, T square is down, whereas here T square is in the numerator. Okay, so that's why it cannot be a correct equation for this particular graph. We'll go to next option. Okay, I have less space, so I'll just erase this. I have seen already that the first option is not correct. We'll go to the next option then. We'll go to the next option and see. See, next option is this R of t is equal to R0 e to the power t square by t0 square. Here also t0 square is in the denominator, t square is in the numerator. Directly you can write, if I take logarithm, then it will be ln r0 plus ln r0 plus t square by t0 square. So here again plus is coming and t square in the numerator, so it is not again true. We'll go to the next option. So in the next option I have some similar things here. Okay, so here you look, you have t0 square in the numerator. So in the argument of this exponent function, so here t0 square by t square. Okay, so here if you take ln r of t, okay, sorry, ln r of t it is ln r0 minus t0 square by t square. So t0 square is a constant term again. Okay, so see this equation number 1 and this is actually matching because t square is here. This one will anyway not match because it is see, if I take ln for this, ln with this, so ln r of t will give you here ln r0 minus 2 ln t, kind of this you will get for this. So this is not true again, so D is not true, B and A, B, these are also not true, so C is true here. Okay, C is the correct answer for this question. Okay, I'll just erase other things to show you the correct one. Look, this is R0 by T square into 1. So the correct one is this one. Okay, all right, this is how we have to solve this problem. We'll move on to the next problem. This problem is again very interesting problem. So what does this problem say? A metal wire of resistance 3 is elongated to make a uniform wire of double of its previous length. That means suppose there was a length of some L, now it is actually stretched to double 2L. Okay, this is the situation now. So earlier suppose the resistance is R, let me tell this as R itself, not R1. It was R. R was 3 ohm. So what will be R prime here? So the new wire is now bent and the ends joined to make a circle. That means with 2L length we are making circle out of this straight conductor. It is now become a circle. Okay, ends are like this is bent and ends are made like joined to make it circle. If 2 points on this circle make an angle 60 degree at center, that means if suppose these are 2 points A and B, these 2 points makes an angle 60 degree, this 60 degree here, then what will be the equivalent resistance between these two? If suppose these 2 points are connected with the battery, then what will be the equivalent resistance between these 2 points? Okay, so this is the question. So what is the question in short? Question in short is that there was a conducting wire of resistance 3 ohm which has length suppose L. Now it is stressed to make the length 2L. Then that 2L length or 2L that conducting wire of 2L length or stressed wire is taken to make it a circle. Now you have to find out the equivalent resistance between 2 points, any 2 points on the circle which is making which are making an angle 60 degree at the center. So this is the situation. I'll write down the options here given in the problem. The options are given as option A says it is 7 by 2 ohm. Option B says it is 5 by 2 ohm. Option C says it is 12 by 5 ohm. And option D says it is 5 by 3 ohm. 5 by 3 ohm. Okay. So look here. First of all, this is L. Suppose the area of cross section is A for this initial metal wire. This is an wire, so it has length as well as area, and also it has certain volume, right? Okay, now this has been stretched to make 2L. Look here, the fundamental idea is that when this wire is stretched, it is stretched in such a way that the volume V1 here and V2 here, they will be equal all the time. Okay, so what was the area volume here? V1 is actually A into L. Now here we don't know what is the area of this wire, but we know the length 2L, double of the length. Okay, so what is the A prime then? So it will be AL by 2L, that is A by 2, right? So in this way we can find out the resistance of the new, suppose it is the resistance R is equal to 3 ohm. Now I don't know what it is R prime. So what is this R prime? We have to find out. So we know that R prime will be rho L is 2L by A prime. So what is A prime? A prime is A by 2. So R is actually, suppose it is originally R is rho L by A, which is 3 ohm. This we have to assume. So then you look here, it is 4 into rho L by A. So this is R, we have taken that. So this is 4R. What is 4R then? 4 into 3 ohm. So it is 12 ohm. So after stretching the wire, what is the resistance of the wire or resistance of the new wire? That is 12 ohm. Now let us I'll just erase this part. Okay, let me go to the next page then. Okay, so now look, I have got new wire of having area of cross section A prime and length 2L. It has got a resistance R prime to be 12 ohm. Now see, for a circle or circular conducting wire, if you take any 2 point or any arc, what will be the resistance of that arc? Let us say this is R1 and the whole remaining part has resistance R2. You can see we will get actually 10 and 12 ohm. I'll tell you how it is. So this is R2 is the resistance of the remaining part and R1 is the resistance of this particular part, which is making an angle 60 degree. First, let us say this is A, point B, and I have to calculate equivalent resistance for this particular like point, okay, between these 2 points. Okay, so resistance of any arc actually can be written as, suppose this is R1 for this particular part. R1 is equal to the angle it is making at the center, that is 60 degree, divided by the total angle subtended around the center. What is the total angle for this circle or the whole arc? That is 360 degree into the original resistance of the wire, that is actually R prime, which is 12 ohm in this case. Okay, originally it has resistance 12. Okay, so then it will be 6, so it will be 2 ohm. Look, this will be 2 ohm. Similarly, R2 means this whole arc, it has, see, 300 degree divided by 360 degree into R2, that is 12. Okay, this will be like this. So this will be 10 ohm. So R2 is 10 ohm. So we have got now resistance for two parts about this. Okay, now look, I have got 2 ohm here, 10 ohm, and see, it is kind of, you know, it is kind of this. I mean to say these are actually parallelly connected to each other about this point or between these 2 points A and B. Between these two points A and B, suppose I have A point, B point, okay, this is R2, say, this is, so what will be the equivalent resistance? So these are actually parallelly connected to each other. So in circle, even if you have a circle like this, so at the middle point, so this part, suppose this has resistance R1, this has resistance R2, so this will be actually parallelly connected to each other. Okay, this is how we have to treat. So then what is the equivalent resistance? Our equivalent resistance will be multiplication R1 R2. Oh sorry, parallel means, yes, parallel means multiplication by addition, R1 plus R2. Okay, so what was that? 2 into 10 divided by 2 plus 10. So this will be 2 into 10 divided by 12. So which is 6, this is 5, 3. Okay, so 5 by 3. So what will be the answer here? Equivalent resistance will be 5 by 3. So that is the option D, which is correct here. Now we'll move on to the next problem. This is again a nice problem. I don't know whether I have skipped one problem. No. Okay. Yes, I have another problem, right? So here in a conductor, if the number of conduction electrons per unit volume, number of conduction electron per unit volume, that is number density, which is given as 8.5 into 10 to the power 28 per meter cube, and mean free time we have denoted by tau, that is 5 fs, that means femtosecond. Femtosecond is actually 10 to the power minus 15 second. Okay, 10 to the power minus 15 second is actually femtosecond. Okay, now its approximate resistivity, you have to find out its approximate resistivity, and let me tell you the options here. What are the options? Options are resistivity, you have to say. Resistivity means rho. So it is 10 to the power minus 7 ohm meter, first option. Second option is 10 to the power minus 5 ohm meter. Option C is 10 to the power minus 6 ohm meter. Option D is 10 to the power minus 8 ohm meter. So far, whichever we have discussed, all were from IIT JEE Mains 2019. Even this is also from JEE Mains 2019. Okay. See, you have to find out the resistivity where me, mass of the electron, also is given, that is known to you. Okay, here for this you need to just remember the formula for resistivity, rho. What is that formula? The formula is me by n square. This is Ne, number density, and it is charge, n square into tau. Here m suffix e, that means mass of the electron. This is e square, that is the electronic charge, which is 1.6 into 10 to the power minus 19 coulomb. Okay, so you can see this is just a calculation job. If you remember the formula, then you will get the resistivity. So let us put this values. Ne 8.5 into 10 to the power 28 okay, per meter cube, and this is 1.6 into 10 to the power minus 19, and this is tau, that is the mean free time, is given as 25 femtosecond. That also we can write, and this will be in ohm meter. So I'll write directly because I have done the calculation. You have to also do it with quiet mind. Okay, so the value will be nearly 1.6 into 10 to the power minus 8 ohm meter. Here actually, uh, this guy has square of it, otherwise all are just numbers. You can actually see, you have to say of the order you have to, okay, so the order of the resistivity, if you write, that itself will actually, uh, if you can just do a rough calculation for getting the order of the resistivity, that itself will actually help you to guess the answer. All right, we'll go to the next problem. Okay, so this problem says determine the charge on the capacitor the following circuit. Determine the charge. Determine the charge on the capacitor. Determine the charge on the capacitor in the following circuit. Okay, I'll give you the options first. First option is 2 microcoulomb, sorry, 2 microcoulomb. Second option says it is 200 microcoulomb. Option third is 10 microcoulomb. Option C, and option D is given as 60 microcoulomb. So look here, when you have this capacitor in a circuit, so we have to find out the charge on this. Okay, so when you have a circuit, DC circuit, when you have a DC circuit like DC battery, along with that you have a capacitor like this. See, at steady state, when it will, the circuit will, or the current will become constant or reach to a steady state. At steady state, that means after a long time, capacitor behaves as open circuit, or actually, yeah, behaves as an open circuit or open path, we can say. That means this part got cut off at steady state. Then I have this equivalent circuit. For the time being, you just forget this. At steady state, only this part you have. Okay, because this is open circuit, means there will be infinite resistance, so no current will flow. So current will flow like this now, like this. Okay, at steady state. So we can find out the current in the circuit the total current in the circuit which is actually drawn from the battery of this 72 volt, that will be calculated from the equivalent circuit. See, what will be equivalent circuit? See, I have 6 ohm resistance, okay, in series with so these two are series and parallel with this. So 4 ohm parallel with 2 ohm plus 10 ohm. I hope you agree with me. So these two guys are in series, which is parallel to 4 ohm, and then the whole thing is in series with 6. Okay, this is what I have written. So this will be actually the combination of resistance here. Now if we try to calculate the equivalent resistance for this, so equivalent resistance will be 6 ohm plus 6 ohm plus 4 ohm. This is 12, right? This is 12. So 4 ohm and 4 ohm and 12 ohm, they are in parallel. Okay, 4 ohm and 12 ohm is parallel. So that we can write equivalent resistance multiplication by this. So this will be actually 3 ohm. So this part as a whole will give 3 ohm, which is series with which is in series with 6 ohm. So equivalent resistance will be 9 ohm as a whole. So what is the total current drawn from the battery? So what is the net current in the circuit? I can say net current I net will be total voltage by total resistance. Okay, so this will be 8 ampere. Okay, this is ohm, this is volt, so it is ampere. So I have got I net is 8 ampere. I net means it is the whole current. Okay, now look, I'll just give some name to these branches A, B, okay, and then I'll give C, D. Okay, A, B, sorry, okay, let us say this is the thing, A, B and C, D. Now if I want to get current through this branch AD, see this AD branch, so what is the current? If we want to get that, we need to know what is the voltage across this 4 ohm resistance. Okay, all right, so suppose I want to get IAD current. Okay, so look, voltage across 6 ohm will be voltage across 6 ohm, how much current? Anyway, 8 ohm will be passing through this, so 8 into 6, right? So it will be in volt. This is 48 volt, right? So what is the remaining voltage? So remaining voltage, because these are actually in, okay, so this is, suppose remaining voltage is 4, this is 5 2, so okay, 24. Remaining voltage is 24. Okay, so here now in this branch total is actually 24. Okay, we have to actually find out the resistance, sorry, voltage across CD. We have to find out voltage across CD. Voltage across CD is voltage across this capacitor. So what is this voltage across this 4? Now when this branch is there, when the capacitor is there, then I cannot say these two are in parallel. Okay, so in that case we have to actually, okay, let us go with this current in this branch. What is the current in this branch? So current in this branch will be total 8 ampere, which is actually branched into two. One is along this way, another one is along this way. Okay, so one is, so let me write it first. So it is actually 4 by 4 plus 12. Okay, this is the into 8. So this is the current along ADC, this branch. Okay, so this is the current, and if you see, this will be this 16, so this will be actually 2 ampere. Okay, that means same current is flowing through this also. Okay, the same current is flowing through IAD is equal to ICD. Okay, that is 2 ohm here, sorry, 2 ampere here. If this is 2 ampere, then what is the voltage across this? What is the voltage across CD? VCD will be 10 into 2 ampere, so this will be volt, 20 volt. Okay, so from in this way we can calculate, or we can do one thing, we can calculate the voltage across AD, then voltage across CD, etc. Okay, that way also we can do, because it is, see, we cannot actually say now when the capacitor is there, we cannot say these are actually parallel. So this is kind of pi circuit. So in that case it is done like this. Okay, actually, see, you might be thinking how it comes here, like this formula. So whenever we write, suppose I have a current, you have this, sorry, yes, the same thing, right? Yes, you have this resistance, you have another resistance over here. Okay, and you have current, some I. So this current, say suppose this is 2 ohm here, this is 10 ohm here, and this is 4 ohm here. So how to calculate the current through this branch? So look, this can be done because okay, anyway, so current will be actually V by R, right? V by R. What is the voltage? Voltage is actually the current okay, so look, this is actually done by this only. Okay, so this is I, then I into 4, the branch which is their associated branch, resistance of the associated branch, and divided by the total resistance of the branch for which you want to calculate the resistance. Okay, so this will give you the current through this branch. Okay, current through this branch, say I2, and current through this branch is I1. Okay, so this is how you have to actually calculate the current. If you have, sorry, this is 4 plus 12, 4 plus 12 total branch, total resistance of the circuit, total resistance of the circuit, sorry. So 4 is the resistance of the another branch, and in the denominator there should be the total resistance of the circuit and into the current. Okay, so that is what is done here. 4, so the branch through which we don't want to calculate the current, so this is 4 ohm divided by total resistance of this particular circuit itself. So this 4 plus 12 into the total current which is coming up to this point, so that is 8 ampere is coming up to here, so that's what it is. Okay, so we have got 20 volt across CD. That means this is the voltage, this is the voltage here, 20 volt. Okay, this is the voltage. So we know we have to find out the charge. So if we know 20 volt is there across this capacitor, so we know the charge is actually C into V. So what is then charge? Charge is C into V. C is 10 microfarad and voltage is 20. So look, it is 200 into 10 to the power minus 6 volt. Sorry, this is coulomb. This is in coulomb. C. So it is actually 200 microcoulomb. Okay. So look here, options are there. So the second option will be the correct answer for this question. Okay. So this is how you have to solve this problem, and we'll stop it here for today. Thank you for your patience. Bye.